Hello, everybody. Welcome to this vlog. Good afternoon, good morning, good evening to all the viewers. My name is Satya. Today, I will be discussing about what is the difference between IPv4 and IPv6. Let's start with the differences. IPv4 is an addressing scheme and is used predominantly in internet, and they are 32-bit long. IPv6 is also an addressing scheme. They are not so predominantly used in internet, and they use 128-bit long addresses, right? Then the second difference is IPv4 does not have stateless address auto configuration. That means to say that in IPv4, the router advertisements sent to the downlink host in the same link does not have IPv4 prefix to configure an IPv4 address on the end devices. In IPv6, router advertisement is received by the end host and they are capable of constructing an IPv6 address with the prefix received in the router advertisement. That means to say that stateless address auto configuration is indeed supported in IPv6. In IPv4, broadcasting of a packet is integral part. Like for example, if you want to resolve an IPv4 address to a MAC address, you use a protocol called as address resolution protocol, which is sent to a broadcast address. That means to say it is broadcasted in the link to understand who has this particular IPv4 address equivalent MAC address, or if this IPv4 address is already used in the network, right? They use broadcasting IPv4 address space. In IPv6, instead of doing broadcasting is not at all used in IPv6. They join a particular multicast group and then they listen to the packets in that multicast group. For example, if end device like mobile phones or laptops want to listen to a router, then they join all routers multicast address, which is represented by FF02::2, which is a multicast address. So broadcasting is not supported in IPv6. Path MTU discovery, right, is present in IPv4, but the fragmentation is taken care by the intermediate routers also. For example, you send a packet with 1500 byte length to the network, and if one of the intermediate routers has a lesser MTU, like for example 1400, then that intermediate router will fragment the packet, right? It is capable of fragmenting the packet. But IPv4 hosts can indicate with a flag called as do not fragment bit to tell the intermediate router to not fragment it, because maybe the end device does not know how to process the fragmented packets. So, but in IPv6, fragmentation is taken care by the source host only. So the path MTU discovery packet will from the intermediate router where 1400 byte was configured will return back saying that the MTU supported in the network is 1400 instead of 1500. So you have to reduce the MTU. So source reconfigures and sends the packet at 1400 byte. Right? Fragmentation is very less used in IPv6. Dynamic host configuration protocol, which is a stateful protocol. It is used in IPv4 to get an address configured on the end devices and also the network configuration parameters, right? Like for example, DNS name, net BIOS name, like that. In IPv6, however, it is controlled by the router advertisement. In router advertisement, there are two flags. One is managed flag and other is other flag. If the managed flag is set to 1, then your address configuration is also done statefully on the end device, that is using dynamic host configuration protocol in IPv6. If managed flag is 0, then only the other parameters, like for example DNS name, router name, what is the NetBIOS server address, all these things will be configured, but address will not be configured. So you understood, IPv4 dynamic host configuration protocol will configure address. In IPv6 dynamic host configuration protocol may or may not configure the address. Okay. IPv4 uses NAT, network address translation mechanism, to preserve the IPv4 address space exhaustion. As you know, 2 to the power of 32 is not such a big space. We may run out of IPv4 addresses. So that's why we use NATing to use different IP addresses on the private segment, but use a single public IP address when we are going into the internet in IPv4. In IPv6, NATing is there, but it is only used in specific scenarios because we have huge address space in IPv6, right? So specific scenarios are dual stack scenario, and when IPv4 network is transitioning to the IPv6 network. Initially IPv4 address will be there. So before IPv6 is supported in the backbone, then you use NATing mechanism. IPv6 is more secure than IPv4. Why? Because IPsec protocol is an integral part of IPv6. In IPv4 address space, it is an extra manual configuration. So inconsistencies will be there in the implementation in IPv4. But in IPv6, it's an integral part of the stack itself. So IPsec. So all the protocol, all the packets are secured at the IP level. IPv6 includes features like secure network discovery. That means to say that all the network discoveries within the link are secure. That means to say that spoofing attacks by the hackers will be avoided in IPv6 very easily, since it is integral part of the IPv6 stack. Due to less address space in IPv4, attackers can easily spoof an address and create havoc in your network. But in IPv6, since the address space is huge, attackers cannot leverage this particular drawback, right? So address space is used, they have to scan huge address space to spoof an IPv6 address. So friends, these are the main differences between IPv4 and IPv6 address space. If you want to know more in detail about IPv4 address and IPv6 address and other technologies, please subscribe to this channel and don't forget to like the video if you liked it. Thank you. Bye.